So this question starts off by providing this function here. It says P of t is equal to 90,000 times 1.06 to the t power. The question goes on to say the given function P models the population of Lowell t years after a census. Which of the following functions best models the population of Lowell m months after the census? So whenever I see a question like this, I like to just make a relationship between t and m. We know that when m equals 12, that's the same as t equaling 1, right? So this is what we know for sure because there are 12 months in a year, which means whatever I get from my original question by plugging in 1 for t, right? So P of 1 is equal to 90,000 times 1.06 to the first power, which basically just means 90,000 times 1.06, should be the exact same answer I get in my answer choices by plugging in m equals 12. Because again, m equals 12 is the same as t equals 1. So looking at choice A, if I replace this m with 12, do I get my 90,000 times 1.06? And we can see that we do not. Right here would be 90,000 times 1.06 to the 12th power, which is already wrong. And I have a 12 in my denominator here. So there's two issues with this. So A is out. How about choice B? If I replace m with 12, once again, I have a 12 in the exponent, which I don't want in order for it to match this 90,000 times 1.06. And I have a 12 in the denominator here. So again, B is also wrong. For choice C, if I replace m with 12, this all becomes 1, which is good. So 90,000 times 1.06 to the first power is exactly what I want. But again, I still have this divided by 12 down here, so that's not exactly what I want. And then lastly, choice D, by replacing m with 12, this whole thing becomes 1, and then I get exactly what I want, right? I have 90,000 times 1.06 to the first power, which is exactly this, which means that choice D is equivalent, the function r of m is equivalent to, so r of m is equal to P of t when m equals 12 and t equals 1, because that's exactly what we'd expect to happen.